All right, ladies and gentlemen, welcome back to A.1.9. Mr. Anderson again, coming to you with our CPM Common Core Algebra last lesson of the appendix. It is the ninth one. We are continuing our journey using algebra tiles to solve for x. And some of us are going to be ready to move on from the algebra tiles and just use some simple manipulations, okay? So today we're going to be, as I mentioned, investigating and identifying what x is. The goal, of course, is to solve. So how are we going to be simplifying? We're going to be using algebra tiles to create some of those legal moves and hopefully documenting those correctly. We are going to be making every single effort to solve or get the variable all by itself. There is, of course, as we've already discussed, more than one way to do some of these simplifications, but we might scratch the surface on something today that might be a little uncomfortable for you, right? There may not always be a solution. So let's go ahead and do some investigating here. For the purposes of time, as we're starting with A88A, right, this guy right here, I already built this for you. Okay, and you don't need to build this. I'm going to have you try to build the next one. But this is A88, and I'm going to, as I'm doing this problem, I'm going to try my darndest to document all my work. The hardest part might be to try to write down what it is that you see. And try this with me. Let's try the left-hand side, top then bottom, then the right-hand side, top then bottom. So I'm going to start over here on the left-hand side with x plus 1 plus 1 plus 1, right? Just took care of the entire top right there. And then on the bottom, we're taking away a x and we're taking away a negative 1. All right, that looks pretty good for that left-hand side. Now let's move on to the right-hand side. Okay, equals, right? Left-hand side of the equal sign, right-hand side. I've got a negative 1, I've got a positive x, and another negative 1 up top. I'm going to slide this over a little bit. And then down below, I'm taking away an x, and I'm taking away a negative x, and one more subtraction of a negative x. Now, I'll admit, that doesn't look very attractive right now, right? There are some things that you guys know you can do in order to make this a little easier. Let's talk about them, but let's use the algebra tiles to help, right? Step one always is going to be to drag what's on the bottom to the top and flip that sign. And I've got one tile that's off the screen there. So let me slide this over, drag these to the top, and we're going to flip those signs. Okay? Now everything's up on the top. Should be much nicer looking. And how does that look when I do my work? Okay, let's see this here. I've got x, I've got plus 1 plus 1 plus 1. I'm going to write this as adding, right? We're just oftentimes better with addition than we are subtraction, which is why we do things that way. Okay, and I've got a negative 1, I've got a positive x, I've got a plus negative 1, I've got a plus negative x, and then I've got a plus x and a plus x. So again, the only thing I did was dragging things from top to bottom, switch that sign. Next is going to be to eliminate some zero pairs. And what does that look like? Well, I'm going to take these and I'm going to get rid of them. And then I'm going to take these and I'm going to get rid of them. Okay, so how does that look here? Well, I will simply, as I'm showing my work, just cross things out that are opposites, right? I got rid of an x and a negative x from the left, and I'm going to get rid of another x and negative x from the right, and that's all the work that I need to show there. If you'd like to rewrite, you certainly can, but rewriting may be more prudent in the next step. Okay, some of us like to do this. We like to take these things and do some organizing, right? Just kind of stack these things, right? So we've got some stuff that's organized or you know, in line. Okay, I put my x's together over here now. I've got some negative 1s together, and I've got some positive 1s together over here. Now, how does that look right here? Well, I've got 1, 2, 3, 4. That's confirmed by what I saw here. So that just turns into a 4. And now over here, I've got a negative 2. Let's see. There's that, and then there's that. Okay, yeah, that definitely makes negative 2. And then what else do we got? We got an x and x, so that looks like 2x. Do we see that? Yeah, so that's okay. So we're looking pretty good. I've got all that mess that's simplified into 4 equals negative 2 plus 2x. Now let's finish this thing off and let's solve. Let's take these two from the the right-hand side. Let's bring them over to the left, right? Some of us like to get our variables on the left. That's okay. I'm going to just bring them to the right. I'm sorry, I'm bringing the numbers to the left, leaving the variables on the right. Sorry about that. Okay, and that's what that looks like. Now I've got 6 over here, and what does that mean here? Well, I took them from here, and I'm bringing them over. They cancel, right? I've created that 0 pair, and now I've got a 6. And again, if you would like to, you can come back here, you can add 2 to this side, add 2 to this side, realize that you've got 2 0 pairs, and drag them off. I'm just trying to save myself that step, and now I'm going to go and organize these. I'm going to do that division by 2. I'm going to organize these into like 2 sets of tiles, and you're going to see, I think, what some of us suspected already, right? I had 2x over here. I kind of cut it up into 2 rows. I split what I had over here. I had 6. I cut it up into 2 groups of 3, and that division by 2 looks like this. Okay, and there's my solution, ladies and gentlemen. We could, of course, check this by plugging this back in up here. We could even plug it in up here. It might be a touch messier, though. All right, next step, we are going to check out B. And when we check out B, I do not have this one built yet, but this one's a slightly easier build for you. Please pause your camera right now and build this diagram. Okay, hopefully you got this diagram built, and I'm going to check mine out in just a moment, but before we do that, I am going to write down exactly what we've got here. I've got a couple of y's on the left-hand side, so that's going to be a y and a y. Now I'll drop down, look at that denominator. I've got a -1, taking away a 1, taking away another 1, and then I'm taking away negative 1s. Sorry about that. So it's going to look like this. And then I'm taking away a y, and then the right-hand side, and I'm out of space, so I'm just going to kind of separate it like that. I'll clean it up in a second. But on the right, I've got a -1. I'm adding another -1. Maybe you wrote that as subtraction. That's okay. But then I'm subtracting a -y. We've got everything set up. We've got it in the algebra tile form. We've got it in the symbolic form. And ladies and gentlemen, now we're going to go ahead and do some manipulation with those tiles. And the first legal move is always to take these items from top to bottom and switch the sign. Some students have sometimes a complication with a problem like this because they are, they're using y's this time instead of x's. That is not a big deal. Okay? Now what I'm going to do is I'm going to take my equation, that I wrote over here, and I'm going to clean it up a little bit. I'm going to rewrite it down here, and then I'm going to rewrite it with those signs switched. So what does that look like? It's going to be y plus y. I rewrote that as a +1, and then another +1, right, because we switched the signs on those ones, and then plus a -y. And that's going to be equal to still a -1, and I can put that in parentheses, that's no big deal, plus a -1, but then a plus y. Okay? And that really mirrors exactly what we've got over here. We're now in pretty good shape to do the next step, which is going to be the canceling of 0 pairs. So I drag that off. That's the only 0 pair that I have. Okay. Now let's see what just happened there. Well, I took this and that and cancel them out. All right. Well, what else do we got? Okay. Another legal move that we have says that I can take the exact same item from the left-hand side and the right-hand side, and I can cancel those as well. Notice I've got a y over here. I've got another y over here. Take those, drop them off. And what does that look like for me? All right. Oh, okay. I've got a couple things left. And let's identify what they are. Okay, I've got a pair of unit tiles here. They're both positive. We'll call that 2. I've got a pair of unit tiles here. They're both negative. We'll call that -2. Now start thinking about this as I combine my like terms here. I'll put these together. 2 equals -2. And again, you can put that in parentheses. Is this ever the case? Is it ever the case where we've got a +2 equal to a -2? And I'm sure some of you right now are shaking your heads. We didn't make any mistakes. We've got 2 tiles over here. We've got 2 tiles over here, but notice their signs are different. Positive, negative. This is never going to happen. And we've got to deal with this mathematically by saying we've got an equation here with no solution. And that happens. It's not the most common thing in the world, but it is a thing that happens to us, and we've got to be ready to deal with it. And if this is a problem on a homework assignment or a test or a quiz or what have you, we've got to document that effectively by saying, not our answer is 2, not our answer is -2, but we don't have an answer. In fact, we have no solution. If you're trying to wrap your head around that a little bit, you can go ahead and do so by pausing the video, thinking about it, rewatching what you need to watch. But one of the things I want you to investigate with me is what I've highlighted down here, A-89, letter C, right? This one right here at the bottom of A89. Would you please pause your video and build this using your equation mat? Okay, did you build this? And if so, how did it go? All right, if you're doing well, keep on doing well, right? But if you're not, maybe we need a little bit more practice. Let's use these things as we're moving on. I'm going to go a little bit faster through this one. I might show a little less work, and you might see a slightly different spin on this, but let's see if we can determine if there's a solution for this particular problem. We're going to start, as we always do, by taking everything from bottom to top. And if you'd like, you can create some zero pairs along the way. Right. Okay, what do we got over here? I've got a zero pair. Let's get rid of that. I've got another zero pair right here. Let's get rid of that. All right, now what else? Do we got any tiles that are the exact same? And the answer is we do. We've got some X tiles that are the exact same, and we've got a couple of unit tiles. How many do we got that are the exact same? Let's try to stack them up next to each other. Let's see what we can do here. Right, something like that. Okay, we're doing pretty well. And again, the rule that I'm going to take advantage of here is that I can take the same number of tiles from each side. Check it out. I've got 6 over here, I've got 6 over here, and I can do that. Huh. What do I have over here on the left? I got nothing. I also have nothing on the right. Let's check this out. Okay, I took and I wrote this. And we're going to do some canceling of some zero pairs. We're going to do some combining of like terms. I've got a zero pair here. Let's see. I've got this is going to turn into a positive one. I'm going to cancel that. All right. Any zero pairs on the left-hand side? Nope. What happens here, though? Oh, I'm sorry. I missed a sign on this X. I wrote something wrong. Let me correct this. This X should be negative. Sorry about that, because that is going to make all the difference in the world, right? Now I can take and I can cancel this X from both sides, and let me just kind of clean this up a little bit too. 3, 4, 5, and 6. This is -6, and this is going to be 1, 2, 3, 4, 5, and 6. This is going to be -6, and at the end I took and I canceled -6 from both sides, and we ended up with this. And that's going to be one of those situations that is always true. Whenever we've got a case like -6 equals -6 or 0 equals 0, that is one of those where we have infinitely many solutions. Right? We saw a second ago, we have no solutions, but in this case we have infinitely many solutions because it's always going to be the case that 0 equals 0. Here's what I'm going to invite you to do. Some of us can step on the gas at this point. We're ready to maybe not use algebra tiles anymore. I'm going to invite you to just do a little bit of algebra here with me in letter C, and then we're going to talk about some review preview. We've got a situation here where we've got 4y minus 9 plus y equals 6. We can do some combining of some like terms. 4y and y make 5y minus 9 equals 6. Let's show that work. Then let's add 9 to both sides. If you're ready for something like this, go ahead and step on the gas, ladies and gents. And now let's get rid of that 5, right? This is what we've been working toward, and we might be there. But if you're not there, then we've got to connect. We've got to figure out what's preventing you from getting there. All right? Ladies and gentlemen, a little bit of review preview here at the bottom. All right? Use Desmos for graphing if necessary. Thanks for watching.